Let's explore the mathematical proof of the power rule, one of the most fundamental rules in calculus. This is the power rule. The derivative of x to the n equals n times x to the n minus 1. We begin with the fundamental definition of a derivative. The derivative of f at x is defined as the limit as h approaches 0 of f of x plus h minus f of x, all over h. For our specific function f of x equals x to the n, we substitute this into the derivative definition. This gives us the limit as h approaches 0 of x plus h to the n minus x to the n, all over h. Now we need to expand x plus h to the n using the binomial theorem. The binomial theorem tells us that x plus h to the n equals x to the n plus n, x to the n minus 1 times h, plus n times n minus 1 over 2, times x to the n minus 2 times h squared, and so on. Notice the first term is x to the n, and the second term, which is crucial, is n times x to the n minus 1 times h. All other terms contain h squared or higher powers. Let's substitute this expansion back into our derivative formula. We get the limit as h approaches 0 of all these binomial terms minus x to the n divided by h. The x to the n terms cancel out, leaving us with n, x to the n minus 1 times h plus the higher order terms, all divided by h. Now we divide every term in the numerator by h. When we divide each term by h, we get n, x to the n minus 1, plus n times n minus 1 over 2, times x to the n minus 2, times h, plus more terms with h. After dividing by h, we have nx to the n minus 1, plus several terms that still contain h. As h approaches 0, all these h-containing terms vanish. Finally, we take the limit as h approaches 0. The limit of nx to the n minus 1 is simply nx to the n minus 1, since it doesn't depend on h. The limit of all the remaining terms equals 0, because they all contain at least one factor of h. As h gets closer and closer to 0, all terms containing h disappear, leaving only our final answer. Combining everything, we arrive at our final result. Therefore, the derivative of x to the n is n times x to the n minus 1. This is the power rule, proven directly from the definition of the derivative using the binomial theorem and limits. Let's verify this with a concrete example. Consider x cubed. The derivative of x cubed equals 3 times x to the 3 minus 1, which is 3x squared. Let's review the key steps in our proof. We began with the fundamental limit definition of the derivative. We applied the binomial theorem to expand x plus h to the n. We canceled the x to the n terms and divided everything by h. Finally, we took the limit as h approaches 0, eliminating all h-containing terms. The result is the elegant power rule that we use constantly in calculus to differentiate polynomial functions.